series. Hello everyone, welcome to today's webinar, part of the 2024 webinar series, Design Timber. My name's Matt Milton. I am Editorial and Publications Manager here at Timber Development UK. In a minute, we'll be hearing from the team behind the fantastic Spruce House, but just while everybody's arriving, I'm going to say a few quick things about Timber Development UK. We are both a young organisation and a very old one in that we were formed in 2021, merging Trada and the Timber Trade Federation, the TTF. So in bringing those two organisations together, we're now a representative of everyone who works in the timber sector, from supplier to specifier, all points in between. And here you can see our three key missions. We carry out these missions via events like this one, and via our ever-expanding resources library, and via all the work we do with policymakers and politicians. Here's just a taste of some of the things we put out. You can see our magazine, Designing Timber there. That's a quarterly magazine, especially for everyone who designs with timber, say architects, engineers, interior designers. We also have a sister magazine, Supplying Timber, which does very much the same thing, but for the supply side. You can see an example there of one of our case studies, Durley Chine Environmental Hub, another fantastic building. We have a whole library of these resources. So if you have a timber project and you'd like to see how other people approach similar timber projects, dive into our case studies library. It's a fantastic resource. There you can also see an example of one of our timber knowledge sheets. That's the embodied carbon data for timber products. Fantastic resource that can help you understand the embodied carbon footprint of your timber project. And you can also see another one of our publications. That's Timber Policy. That's an interesting publication that looks at how other countries across the world are incentivizing timber, either regionally or nationally. So do investigate our resources library. There's a lot of great stuff in there. Being on, I'd also just quickly like to tell you about an exciting event that's coming up in June. This is the first ever UK Timber Design Conference, great one-day event on 26th of June 2024. We'll be hearing for all manner of people right across the timber spectrum, and also not just from the timber spectrum. We'll be hearing from policymakers, house builders, clients, hearing all sorts of perspectives on how we can build better with wood in the UK. So yes, we urge you all to join us. I'm sure there are lots of members watching this webinar, but if you're not already a member, you really, really should join us. There's all sorts of benefits. I hope I've shown you just a few of them, but we're also very excited about Find Your Timber Partner, a new resource we've created. Now, this is a shop window, if you like, for your business. It enables you to tell the world what you do, to advertise your projects, your products to like-minded people. So yeah, it's a great shop window for potential new clients and potential new partners. So here's a quick look at other webinars coming up in the series. We know you're going to enjoy this one, but do keep an eye out for the other ones coming up. Lastly, we do encourage you to enter this year's Wood Awards. So if you've got a great timber project, do make sure you enter. The deadline is looming, 24th of May. So do check out the Wood Awards website to see a few examples of past winners. Without further ado, I'm going to move on, and we're going to start with Zach from AOFT. Do make sure you all make use of the Q&A button. If you go down to the bottom of the screen, you'll probably see a little icon for the Q&A feature. Feel free to ask anything you want to ask of our panelists as we go along, and there'll be time to answer your questions at the end. So I'm going to hand over to Zach. Go.
All right. Thank you. Let me just set up the screen here. Okay, how's that? Is that full screen? Okay, hi everyone. Welcome. I'm Zach from AOFT. We are a London-based design practice led by Liz Tataran-Seva and myself. So as a practice, we pursue an architecture that links the cycles of nature with the built environment. This ambition is guided by our interest in working with natural renewable materials and fabrication construction techniques. Currently, our focus within the practices is on urban residential projects within London. So Spruce House is our first built project. It was a new build house and studio on an infill site in Walthamstow, London. The project began in 2017 and began on site in early 2020 and then completed in 2022. So the site is located in a conservation area and it has a really fascinating history, as it used to be the village high street. This can be seen in the street elevation here, where over like the past 100 years, the street transformed from retail spaces to residential. There's also several different typologies that can be found within the streetscape, from villas to model cottages to former shop fronts. And as you can see, many of them have a mixture of alterations that have been done to them. And this really kind of inspired us. So from, looking at the streetscape and kind of understanding the area in further depth, we really kind of set out to understand its history of the area. So we kind of dug through the planning portal. We went and searched the microfiche at the Waltham Forest Council. We also went through the local Vestry House Museum photo archive to kind of uncover what was once there. So this research led to this timeline here that you can see, where it kind of revealed that this kind of single family house that was there used to be occupied by two shops, which was a stationery and a bootmakers. And this was really the beginning within the design process of kind of understanding kind of what could be the design question of really what could be a contemporary residential shop front. So here it is. Here's what the original 60s infill looked like, the front facade. And beside it, you can see the shabby shack. It's a really nice Victorian shop front that you'll see later in the design process was kind of key for the setting out of the facade. Here is the rear of the house when we arrived. Basically a bunch of random sheds in the back, and then kind of a lean-to kitchen off the back. So after kind of receiving planning and getting into the design of the process of construction, it really, the process for us, even from when we were going into planning, was really, wanting to construct with a renewable material. So we kind of researched several, but in the end, we kind of decided on CLT for several reasons. I think one of the main ones that we found really advantageous about it was that it could we could split the contract into three separate contracts and not have any of the trades kind of overlapping. So those three were kind of demolition, groundwork, steel, CLT, and then finishing. So the first part, the demolition, so that started in January 2020. Propping the two sides of the building, and this was really the no going back moment. Then came the CLT installation. Jim will be talking more about this later, but this is the sequence of the paneling going in. Essentially 46 CLT panels. It was done in 5 days, and it's sequestered 37 cubic tons of CO2. Here's just a video after the final day of installation. we flew a drone over the top of it to document it within the two buildings. So immediately after the installation of the CLT, our main contractor, PSS, came on site. They initially covered it that day with a tarp, but was quickly changed over to scaffolding a couple days later. And when they came onto site, they essentially constructed a temporary workshop and storage within the garden. So Prachemik, Slavic, and Derek kind of fabricated most of the elements here on site, and they were really intrinsic to helping us realize this project and our design ambitions. So now I'm going to kind of show a couple examples of like what they helped us together with our drawings kind of achieve these kind of specific details and kind of show a bit about what happens to the CLT after it's been assembled. So there's kind of several of these key ones, but one of the main ones is actually the light fitting for the downlights, because we wanted to have them embedded within the CLT panels. And it's quite a straightforward process to how this detail was thought through with them, where we essentially used a hole saw to create a larger hole in the top to allow the downlights to tilt, but also so they wouldn't overheat, to allow air to circulate around them. But this was really quite an integral detail. And here you can see after first fix the lighting. But then, so really key for, you know, how the space feels. And we really wanted to make sure that, you know, we were really connecting to the exterior, both inside and out. So here, you know, we didn't want any lighting to be hung from the ceiling. So here you can kind of see in the image where the misting system as well as the lighting is kind of put into the CLT panel here on the ground floor. So next, I think a really important aspect to realize about the CLT is that when it is delivered, it's not finished. There's still finishing that needs to be done. So here, Thomas was sanding. Well, we sanded all the CLT with this large disc sander, and essentially that was done in order not to create any flat spots within the panels, to keep them as even as possible. And so next went on the intermescent paint, followed by the Osmo. So this was a really important aspect as well, to kind of do the finishing on site rather than having it done in a factory, as it was an infill we wanted, and we were going to be building within it. You know, we wanted to make sure that it could be, we wanted to save that process till the very end. So here are kind of three key interior images, and I think they really kind of highlight the quality of PSS's craftsmanship, as well as kind of shows the limited palette that is kind of encapsulated within the Spruce House. So on the left here, you'll see the CLT fire doors that were developed with a fire engineer. They're full height, and they have the intermescent strip for fire and smoke that's rebated into the CLT panel, as well as using intermescent hinges. The bathroom image here in the middle with the terrazzo in the mirror, this is something that we kind of use throughout the house in order to kind of hide electrical and plumbing. We kind of faced different spaces with a different material. And then on the right here, the kitchen, which is also constructed with a 22 mil thick CLT. And here you can also see the powder coated perforated metal sheeting that is also acting. It's also hiding ventilation in the back. and the steel countertop. So now I'm going to kind of go into just a few of the other kind of key designs of the house and the details that kind of were created for them. So I'm going to start here with the front facade. So the front facade really began with an analysis of the neighboring traditional Victorian shop front. That is what essentially helped us in terms of thinking about the scale, the datums, proportions, and the glazing. And the decision to really align to this building was to instill a sense of continuity and rhythm within the street. Next, because the front elevation was wider than its neighboring buildings, we felt it was appropriate to express the verticality of the building. So here we've used the full height Siberian larch glulam to do that. And as you'll see on the rear elevation, that's also incorporated into another aspect of the design. But the design intent here is really to accentuate the rhythm of the neighboring shop front. And then finally, we took the idea of this, contemporary residential shop front and really worked into the ideas of, what is, how could we make this space within private, but also let in light. And so we created this privacy in between the vertical glulams, and they're, they also kind of help to express the full height, the verticality within the neighboring, within the building. So kind of as we were drawing that, we were also testing that through models, physical models. We use that a lot in the studio to kind of help us through key aspects of the design. And from there, when we were on site, and there was a couple of really key details for these kind of opening panels. So in the final detailing here, the two kind of elements that I'd like to point out and share are really in the opening element. So the first is this opening privacy screen, which was really, it was the hinges that needed to be kind of tested and developed, and that was kind of done again on site with our contractor. And in the end, it became a mix of an off-the-shelf kind of stainless hinge mixed with a laser cut stainless steel sheet that kind of had the drilling holes kind of already set within them. The other kind of key opening element is the openable ventilation panel on the first floor. So this again was really a very crucial detail, because we wanted to have the glulams aligned through the facade and appear continuous. So, aligning the timber cladding with the glulam was really important. So, in the end, for this openable panel, it was really the solution was to actually end up going with a butt hinge with a restrictor on it. But yeah, it was quite key, and PSS were really instrumental in making this come together. As well, these openable panels, they are insulated, and they're not solid wood. So here's an image of the final facade. As you can see here, the front door panel is double width, and which actually works really well as in the summer. The screen still provides privacy when it's closed, but it also allows for ventilation through the building. Yeah, and as you can see, and as I'll show in the next couple slides, that all windows are fixed with all openings being openable ventilation panels. So the next kind of key area here is the dining room area and ground floor. On the ground floor, this detail is really key, and this is one of the reasons that we went with glulam throughout both the front and rear facade, as here the external glulam is supporting the CLT panel in this area, in the dining area. It has a steel L bracket here up in the top that's supporting it. And yeah, as with the rest of the house, the glazing detail is the same, where kind of a spruce capping is attached onto the glulam. And here you can see the final image of that, where really the design intent of the dining area here is to really create a strong connection with the garden and the planting. Next, I'm going to talk about another detail that we worked with Sanja on. That's another really key part of the house, but it's not timber, but it carries a similar logic to that of the CLT. We're extremely inspired by the idea of things being assemblable and disassemblable. So, like the CLT structure, this is kind of, the staircase is really thought of almost as a kit of parts. So each one of the treads is 5mm steel that is been laser cut and then CNC folded, and then it is bolted together. This the prototype was done on with the metal fabricators. We prototyped it, and then really we were trying to conceal the bolts within the perforation, so there was a lot of work there, as well as kind of working on the finishing of the powder coating. And this is this perforation is again kind of links back to this the front door and this privacy screen, and in the summer allowing it to be open because above this is a openable skylight. So this having the perforations, it lets the light in from the skylight above, but it also really lets air circulate through and out of the building. And here you can kind of see the ground floor with the staircase. And this is another kind of key aspect of the overall design within the house, and the idea of layering. This layering of materials, whether it's the privacy screen or the screening for the staircase, is essentially allowing quite a narrow space to kind of extend and appear light within the space. So I'll just maybe now go through the plan. So here we have the ground floor plan with the entrance that goes into the living area, which has the built-in kind of toilet and entertainment center. Then you have the kind of kitchen, the galley, and lots of storage, and then ending with the dining room. Here we have the studio in the back through the garden. Up here on the first floor, we have 2 bedrooms with storage space in the corridor, bathroom, and kind of utility space on the end. And then on the second floor, we have the main bedroom with the ensuite bathroom off of that. So in the sections, I think what's really key is that you can see that the building is sunk down. The finished floor on the ground floor is about 50 centimeters below ground. This is really to again really embed the building within the garden and create a real strong connection with it, as well as a lot of in the elevation here, you can see the amount of stores that's kind of built into the house. That is another really key aspect to the overall ambition of the project, is to create as many built-ins as possible for storage. And then here, finally, the rear facade with the metal fascia that kind of caps the insulation and CLT. And again, this kind of links back to the front facade. Because of the situation of it being a new build, we were able to kind of connect the front and the back. So this is again why we've kind of carried that through. Yeah. So
great, thanks very much, Zach. Do keep your questions coming in. A few have been asked, and so if any of the panelists would like to when you're not speaking, have a look at the Q&A and answer them. But I think I'll hand over to Sanja. We're still doing all right for time, but I think we need to be reasonably brisk. Thanks.
Thank you. I'll try. So, okay. So from the beginning, this is the engineering journey on Spruce House. It is one of the projects that all three of us learned a lot from, and it's a fantastic one. So a little bit about me. My name is Sanja Buncic. I'm currently working for Elliott Wood. And at the time of this project, I was working for a company called Intuitive. I guess I was lucky throughout my career. I was working for companies who always were brave enough to ask what if, and so we really adopted the use of timber and especially mass timber very early on. So I have been working with mass timber since 2008, and this is just a few examples of the types of the projects from all of my previous and current employment. So it is a very vast, broad spectrum of and typology of the projects that I enjoy working on. And timber can find its way to any if you know how to do it. So when Zach and Liz approached to design their home house, we were this is what we got: a terrace building, a traditional Victorian terrace, 2-story, nothing remarkable about that, which has been developed and cut and carved throughout its history. It was not in a really good condition. Everything inside was really, really poor. The garden was overgrown. The neighbors were also starting doing their own refurbishment works. And so we really thought that it was an open blank canvas that we can just work with. And the idea of using CLT actually came from Zach and Jim, who paired and proposed this, and we obviously jumped on it because we love working with timber. And so, oops, I'm sorry. Yes. So the initial proposals were basically when you start a design of this house or a project like this, a few things that we as engineers like thinking about is how to provide lateral stability of the building, especially when you have a building that is relatively narrow and very open. We also, in the use of CLT, we also had to think about the fire and durability and most of all installation and problems during the installation. And so a typical way of working with an existing Victorian stock, which doesn't have straight walls and doesn't have straight lines, and it has been built and rebuilt in the past, is to provide a set of steel beams across and steel frames across the building, and then just use the CLT as basically infill. But as we found out during the tender stage, this is a very expensive way of thinking. And so Jim has suggested, what if we remove as much steel as we can and keep just the absolutely necessary ones that are required to achieve lateral stability of the building and provide supports where we need them, but we actually use CLT as a structural support as well, and not just as an infill. And so this is the revised scheme that we have basically come to. Now we are going to spot the difference here, but we have managed to significantly reduce the amount of steel, and the blue vertical frames lines, those are the two elevations where we had to provide steel for the lateral stability support, and because we didn't have any walls in that plane on the ground floor, and the only steel that remained was basically a trimmer around the stairs, which we had to provide to support our first floor and the second floor structure. And so going into the detailing of this, at the back, we were faced with a very unique challenge, and that is that our next door neighbor started their own works. So some of the details had to be developed while they were on site or during the design, because our construction hasn't started that quickly. So they have already progressed with their works. And so we had to basically revise some of the details and had to come up, which actually helped us in the end, because we created a party wall, which was non-typical. And I'm not really sure if we would be getting the buy-in at this day for something like this, because it's not conventional. It's a cavity wall with an external brick and internal, obviously, insulated cavity, and then internal CLT panel as the internal block. But to make building control a little bit more, well, a little bit happier, we have provided steel, almost like wind posts, which were providing the lateral stability of this part of the building. And obviously, we had to do these works much before our neighbors. And so one of the challenges was the sequence of the build here. And so basically what we did was we built the single skin brick first and had to come up with an idea of how to install the wind posts and the CLT panels, and fixed all of that later, which was a little bit, it made us scratch our head a little bit. But that was done by carefully marking on the exact positions of the wind posts on the concrete floor slab, and then post fixing through the CLT into the steel posts. So this was done really accurately, and the results you can see, it is really brilliant, I think. Another, oops, not really sure why it's not working. Yes. One of the challenges that we had was an open plan at the ground floor, and how to hide existing steel or proposed steel into all the finishes. And so we were really limited by the size of the existing floor panels, because they had to be designed for fire as well. And we had to have a sacrificial layer at the bottom because the top was protected by finishes. So the steel providing lateral stability was really tiny, only 120 mil thick, but that allowed us to basically hide it completely, and it's really not visible on this, which was, I think, it took us a while to come up with a solution, but we managed to do it in the end. One of the challenges, and again, it might be irrelevant and small, but actually when working with relatively large spans and not a lot of depth of the structure, is how to provide a lot of support for the first floor level CLT, including the walls that are supporting the second floor and the roof. And so we had to use a steel beam which was fabricated out of two very tiny SHSs, welded together, brought into site, and supported by a box frame in the front facade and a small tiny toothpick column hidden in the timber wall on the other end. And this trimmer was also providing a restraint for the steel posts which are part of the balustrade screen of the stairs as the lateral support for that. The rear extension, the single-story rear extension, was really a challenge for two reasons. One was it had to be laterally restrained, and so we used the roof of the, and obviously we didn't want to have any steel visible to provide that, we were restricted by the size of the glulam posts, the connections at the bottom and the top, and also what they can restrain. So we have used a combination of those glulam posts acting as cantilevers, prop cantilevers, transferring the force into the diaphragm created by the roof of the CLT, and then picking up those forces within the party wall line, because we had a lot of walls there, and so we could do that. And so the roof was designed as a diaphragm and it is installed, and all the connections obviously had to be hidden. With the durability of mass timber, that whether it's glulam or CLT, it is really important to protect it from the ingress of moisture. And so external glulam was raised from the ground. So we had a concrete upstand, which extended at least 150 millimeters above the ground. And also we had timber that was fixed to the concrete upstand through a T-shaped bracket, and the timber was also raised to just decrease the chance of moisture and water splashback. There was a really good question in the Q&A chat about how to protect the CLT from moisture ingress. We had underpinning in a new concrete slab. There was a layer of waterproofing membrane on top to prevent timber from, or any structure and insulation, everything else from the damp from the concrete slab, and that extended to a certain height. Also when a timber panel, a mass timber panel is installed, it usually doesn't sit directly onto the ground. There is a rail, bottom rail plate, which is fixed to the concrete slab, and that bottom rail plate is usually protected by a like a damp-proof course or some kind of a plastic sheet membrane that prevents moisture ingress getting into that. For the stairs was the stair structure looks really simple, but it made us scratch our heads a few times, and the main challenge was the fixing of the stringers into the CLT. So the steps were made out of 5mm thick plates with 6mm diameter perforations, and so the idea that we had was to use 6mm diameter screws for fixing the stringers into the CLT. And that was challenging, but we managed to basically achieve that. In order to help us reduce the forces that will go to the end of a stringer, we have used the balustrade posts, which are tiny. I think they're 40 by 40 mil, something like that. They're really, really tiny posts. They helped us support the stringer on the end closer to the room. But I think the steel fabricator here was a real star, and this wouldn't be possible without them. One of the challenges with the stair was, and this is probably something that we didn't think about at the time of designing the stair, but then it became, when the design was done, it became apparent that we have almost a meter of very thin CLT panel that cantilevers off the line of the support of the wall on the ground floor. And so we had to use, on the left-hand side, you will see the top left corner. It is almost like a vertical balustrade panel that extends, and that was designed as a cantilever to help us restrain the bottom of the landing at this end, because there is a CLT wall going all along there. There was a question about the fire, and I think this is probably, we will probably be able to answer that. So in 2020, the Structural Timber Associations has published a set of guidance on how to design safely timber buildings for the fire load and fire design. All buildings are in that guidance divided into 4 classes, 1, 2A, 2B, and 3, and that depends on the consequence of the fire in that building or that structure. When we are dealing with a building of this type, which is a single occupancy house, less than 4 stories in height, the consequence class is really low. And so we could approach the design of CLT by either guidance-based approach or a performance-based approach. And so I believe that our fire engineers have advised on the guidance-based approach, and which meant that we could use guidance from the approved document, providing that the fire spread of the internal linings complies with the building regulations. And so to achieve that, we had to paint all the visible faces of CLT, floors and walls, with, I believe it was, we used EnviroGraph as a product, which will obviously need to be reapplied at some point. But that helped us go over this hurdle. The CLT was also designed for 30 minutes to sustain a fire for 30 minutes. So we had to, Jim will talk about that as well, because it was really important for us to source the right, not just the CLT that is of the right thickness, but the CLT that is made out of correct lamellas. The thicknesses of lamellas were really important. Zach did mention all the design that happened with the fire doors and fire stopping. But the building control was happy with this approach. They were also happy because we had sprinkler installed as well as an additional measure for this, which is over and beyond what a building regulation would require for this case. So we started a journey here with a house that is forgettable and needs a lot of care and attention. I think we ended up with something that looks really fantastic and welcoming and really well designed. So yeah, that was us. Thanks.
Thank you very much. Great presentation. Yes, so we're going to move over to Jim.
Let's just do the share screen thing. Share. So, hello there. It's been an interesting project. This one, it's been 2017. I think it was the first time Zach and I spoke about it. We met over a coffee in London Fields, and Zach expressed his intention as to what it was that he needed to do. And let me just hang on a second. Here we go. So Yeah, so Zach's first approach was that he wanted it to be an uninterrupted ceiling all the way from the front of the building to the back, and everything in the long span, which, as Sanja mentioned with the steel, would be quite expensive. So we started to talk about how to do it in a way that was uninterrupted, gave that flat ceiling, and allowed us to demonstrate the beautiful socket that we see in our later pictures. So there we go. Key to us when we started was the quality of the design. From very early get-go, we had frozen drawings to work from. We discussed all of the intentions, and Zach and Liz got down to sort of producing some very accurate drawings to work from. I mean, this was going to be built in a space where a previous building had been. So we're working with tolerances, trying to maximise the space, and trying to allow us to get the CLT in. It was the first time that we'd worked on a house like this, where the whole house had been removed and a new house was being put in. We previously worked on real extensions and such like, or houses just sitting out in their own space. So this was a new challenge, because we didn't know what the walls were going to be doing. We were going to have to prop it. We were going to have to deal with all sorts of different restrictions that made it quite an interesting challenge. There we go. So this was the ground floor. You can see very open space. Then we go to the first floor with a few internal partitions. Also, I think, yeah, hang on. And we've got some sections, and you can see the amount of detail in dimensions that had gone into this. So it allowed us to model it very accurately, and so we were confident that we were going to fit it in, as long as the two buildings were still in the same place after the other one had been demolished. So here's Sanja's bit of information from Sanja. We had extremely good technical details as well. So we were just worrying about modelling it and what were the logistics that were to come, because the building itself had been designed with all of the details that Sanja mentioned, and this is an example of the information that we received, which is key is the frozen element, the fact that we can start to design this building without having to go back and make lots of changes, and be confident that the intentions that we have are going to work. So we got down to the timber design. We've seen this already in animation, so I'll leave it as it sits, but we actually did change some of the sequence. This shows that the sequence runs from back to front, from front to back. We actually worked from the middle to the front and the middle to the back on the first floor, just because of working within the steel and working within the propping of the building. So we created our 3D model. There is an IFC of this that I might be able to show at the end. It was a bit slow loading, so we're just showing a PDF of it at the moment. But you can see how the steels were incorporated. We didn't actually provide the steels. The steels were part of the groundworks package, and so we were very reliant upon the accuracy of the initial install of these steels. And we have to say that we were very happy with the way things went, happy with the upstand, happy with the steels, and it gave us an opportunity to introduce our panels without any real adaptation or the need for any cutting. So that was a good position to be in. We then create that from our 3D model. We will create our panels, and each panel we use a company called Timber Concepts. You'll see there. They do our DFMA stuff for us, so they work very closely with the manufacturer. And in this case, we went to Skonto. We initially looked at various manufacturers, and on price point at this time, Skonto were the ones to go for. They promised us the level of visual that we required, and so we were happy to use them, and they turned out to be a very good supplier. You'll see, we can't see because it's too small a detail, but over here we have the, can anyone see the mouse? I guess you can. This is where the wind posts were, and we cut out the bottom of the panel to identify where the posts were sitting so that we could see exactly where they were when it came to connecting to those. And so they were installed by us prior to the CLT going in, and then we connected using self-drilling self-drilling screws to connect the CLT directly to the wind posts. Here is our sequence of floor slabs, and we worked from the centre out to the front and out to the back. Same scenario with the next floor up. All our panels are numbered. You can see that there's red there, or the red indicates whether it's industrial visual or whether it's non-visual. We went with industrial visual for this because Zach and Liz understood that there was going to be a need for finishing work to be done. So they wanted a decent canvas to work from. They didn't expect it to be fully finished, but they wanted the quality of CLT so that they could then take on the finishing of it with the follow-on trade. And so this gave them, I think, gave them exactly what they wanted, and I hope they agree. Then up to the next floor and sections, so all of our details. We provide all of this information back to Liz and Zach, who then proceed to approve the drawings, and we go into production. The key to this project, probably for me, is the logistics. It's in the middle of Walthamstow village. As Zach said, it was a conservation area, and access was challenging, I think is the word. So typically, the CLT will all come on an articulated lorry, and the factory will provide us with a loading plan. They'll show us where every panel is on that lorry, and we have a bit of control. What we will do is we'll specify pack weights, because we knew we were going to have to unload this away from site and put it onto smaller lorries. We stipulated that no pack was heavier than 1.5 tonne, which meant that when we were unloading, we were never lifting say more than 2 tonne, when we take into consideration the lifting equipment. So here you'll see how each pack is identified. We get a list telling us how and where each panel is and how it's packed. We'll know the weight of each panel, we'll know the weight of each pack. So what we had to do for this project is decant these off. We took them into Tilbury, and we unloaded everything at the docks, and we stored the packs and then loaded them back onto ridges so that we could deliver on a daily basis, sort of almost just what we needed. So we took this one lorry load and we split it down onto 2 lorries, and so we never had too much material on site. We could also sequence the build because the packs are all made up of panels that work together. So you won't be looking for panel 1 in pack 17 and panel 2 in pack 10 or whatever. You know, everything is organised and sequenced. So that's how we got everything to site, and it all so everything was delivered then as it was needed, so just in time. Part of this logistics was that the guys at AOFT had to produce this construction logistics plan, a very extensive document within which we had to provide information regarding the cranes, regarding the lorries, and then we had to create a route, and within that we had to show where parking restrictions would be, swept path analysis for the vehicles, so that everyone could work out that it was going to happen, it would be okay. Meant that we had to sort of clear some parking bays where it was particularly tight turning the lorry. But all this had to be done in advance, and then the parking restrictions put into place. This all happened then in 2020, which was just as we were coming out of COVID, I think in June of 2020. And so it was quite interesting. There was a lot of people about, and a lot of people watching what we were doing. And I think they mostly quite enjoyed it. So it gave them a bit of an interesting break from watching daytime television. Anyway, so road diversions, the whole traffic management plan had to be designed. Couldn't just be, so I think this all comes under what they call Chapter 28, and everything had to be in place and approved. And so all of this was worked out by a traffic management company. And we're working in this, and you know, I think Beulah Road is here, if you can, and then everything travels around. Just to throw a spanner into the works, because we were coming out of COVID, the number of schools that are in the area, the Henry Maynard School and another one, I think, on off Addison Road, meant that we had to then, the Sherwood Hall Preschool as well, we had to change some of our plans because they wanted to make the roads, they would close all the roads when the schools were opening and closing, so that there was less people. So just added to the confusion. Okay, there we go. So a few images of the building going up. You can see how tight Beulah Road is, and the crane parked halfway down the crane, and lifting the large panels in. One of the things we still needed to keep enough large panels within this project to make the structure work. So the one that you'll see there on the right hand side is the party wall panel, which we had to bring in flat, since we had to feed it through all of the propping, bring it in, we had to lay it down, and then we could stand it up within the structure. So we couldn't take any of the propping out until the building was up to each level. You can see the pre-installed steels are in, and then the middle picture, particularly there's a double height panel that was 160 thick, which was acting, I guess, as part of that lateral support across the building. Can't see that the frame in the middle picture is it what they call a, hang on a minute, I wrote this down, because a bowel drain beam, I think it's referred to. It's a completely square beam that is attached underneath the slab as well, which adds to support. So we had so panels being delivered, so here you can see just the packs. I mean, it's a picture of packs of panels, but they were all sequenced, so we were just moving them in as we needed, and we weren't then creating too much disruption, because we had to have the road open again by 5 o'clock every day. It wasn't something that we could just leave stuff sitting outside, so everything had to move in, and so everything had to be delivered just in time.
Sorry, Jim, I'm just going to have to nudge you along a little bit. So we're running out.
No worries. So quickly, that panel on the left is the party wall panel, which Sanja alluded to earlier on. In the layup of the panel, this was originally a 60mm panel, which would have been 20-20-20 in the lamella. And if you go up to 80mm, you typically would then get 20-40-20. So we specified 30-20-30 to get the sacrificial timber for that panel. We'll whiz through some of these pictures that you've seen. So this is just the building as it finished for us, without the external detailing, just tightly in the space. You can probably see from the roof line that it's very tight. We had about 20mm of space by the time we finished, which was very useful. Some pictures inside. And then I was going to show this one again, but I think it's well, I think this is well worth the view. So, but we just turned it sideways, and you really do get a feeling of how it was shoehorned in to the space. And there we go. And this is the finish. And I think we've all seen this picture about 3 times. I think everybody's used it, but it shows the ceiling that Zach was looking for when we first had the conversation. I think for us it was a successful culmination of the whole project. So that's us, I believe. Yeah, thank you very much.
Thank you, Jim, and
All
thank
right,
you.
Matt?
Yes, thank you. So you can stop sharing your screen now. Thanks. Thank you to all our other panels. We've overrun a bit, so I'm afraid we're not really going to have time for questions. We're going to see if we can answer a lot of them via email, and our panelists have actually answered quite a few of them. So I thought we might just end by asking Zach what this house is like to live in.
Yeah, the living in the house is fantastic. We learned a lot from living in it, but also building it, and living on site. Actually, while it was constructed, we lived through about 9 months of the construction on site. So we learned a lot from that process. But yeah, living inside the CLT house is I mean, we really love it. It's yeah, calming and yeah, nice.
Because there were actually a couple of questions about, I suppose, durability and maintenance and moisture, and I suppose the fact that you live in there is sort of testament to the fact that that interior, does take the knocks and it doesn't require the sort of concerns and maintenance that some people were wondering about.
Yeah, no, it's actually really nice. I think because you have that kind of the wood grain and the texture, if you bang into a wall, or if you visually don't see it, not like make a mark on a white wall and you go to repaint. I think actually a lot of what's great about the exposed CLT is that everything kind of blends together visually.
Fantastic. Well, yes, I mean, even though we could talk all afternoon, we are going to have to wrap up, I'm afraid. So I am just going to thank our panelists once again. Just remind you of the other webinars coming up in this series. The next one is Field Station on 12th of June. A really interesting project, very different to many of the others we've shown. It's a sort of a eco pavilion at Hook Park, designed by students in association with engineers from Arran. So do please go to our website and make sure you don't miss out on that one. But yes, I will thank our panelists again and wish everyone a great afternoon. Thank you very much.